Okay, we're in section 5 of the notes, and these are the examples that we're going to be doing. Um, Again, it's certainly important that you've understood what we've presented to you to do these examples over here, which basically resolve around 4 formulas. And that's the sine of a plus b, the sine of a minus b, cosine of a plus b, and the cosine of a minus b. So the problems that follow have to do with those 4 formulas. All right. So I'm going to switch the screen, and I'll share my whiteboard with you now. Okay, so problem number 1, what they want me to do is verify that this is not true. All right, so you'd have to know that this is something to do with the sum formulas. So I'll write this down. So they're saying the sine of 45 degrees plus 120 degrees is not the same thing as the sine of 45 degrees plus the sine of 120 degrees. All right, so one thing I noticed about this on the left side, that if I just add 45 and 120, 165, and that would be 15-degree reference angle, and I just don't know that. So I'm going to say I have to use a sum formula for that. And I would need to know the sum formula. So it's sine 45 degrees times the cosine of 120 degrees plus the sine of 120 degrees times the cosine of 45 degrees. And they're saying this is not the same thing as the sine of 45 degrees plus sine of 120 degrees. Well, I need to know the sine of 45, the cosine of 45, the sine of 120, and the cosine of 120. I think I know that, and I'll write this down for you. So it's going to be 1 over root 2. That's the sine of 45. The cosine of 120 is minus 1 over 2. The sine of 120 is root 3 over 2. And the cosine of 45 is 1 over root 2. That's not so bad. The sine of 45 is 1 over root 2. And the sine of 120 is going to be root 3 over 2. Well, let's keep doing the work. And what do you get over there? Well, common denominator, left side, 2 root 2. Well, on the right side, common denominator is still 2 root 2. That's pretty remarkable. Minus 1. All right, plus root 3. And what do you get on the other side? Well, I know it's common denominator, but I have to do some work over there. So it's going to be 2 plus root 6. All right. Now, what am I looking at? Hopefully, you're looking at something that obviously is not equal. And how do I know that? The denominators are equal, certainly, but I hope you know that minus 1 plus root 3 is not the same thing as 2 plus the root of 6. Whoops, 2 plus root of 6. For example, on the right side, that number there is clearly bigger than 4, and that number on the left side is nowhere near 4. All right, it's minus 1 plus root 3, and root 3 is 1 point something. So you're looking at really a fractional number. All right, so that's been verified. That was number 1. All right, I want to point out over here, you know, so put this results down, we're a little different than that. We're root 3 minus 1 over 2 root 2. And the other side, they're really identical. All right, let's go to the next page. And let's take a look at this one over here. Again, number 2 has something to do with a sum form. And I'm looking at it, and what they want me to do is write the expressions in terms of sine, cosine, or tangent of an angle. So I'm looking at this thing, and it looks like a sum formula for a sine. And so I'll write this one down over here. It looks like this is, sine A, cosine B. It might be a different order, but it certainly, it does look like a sine of a sum. And so I can put sine of 127 degrees plus 19 degrees. I'm going to expand that for you so you show the same thing, but we'll put the answer down later. And that's going to be sine of 127 cosine of 19 plus sine of 19 degrees times the cosine of 127 degrees. All right. Now, granted, someone says, why would you write it down that way? Just to show you that it's really the same thing as what they have written over there. Some things have been commuted around, but still the same thing. All right. Now, what do they want me to do? They want to write this as a sine or a cosine or a tangent of a single angle. It looks pretty easy to do. What's it going to be equal to? Again, I'm looking at this over here. sine, and I have to add those two numbers together. 127 and 19 is going to be 146 degrees. Look at the key, and you see that. All right, so I'm going to talk about number 3. And number 3, again, has something to do with those formulas, sine, cosine, and of a sum, and cosine of a sum, sine of a difference, cosine of a difference. So let's take a look at it. There's a footnote over here. I want to point out, look at the footnotes. I have to verify something, and I want to point, they're asking me to verify this over here, and I want to go through with you, right? So certainly you want to be able to do that as well, but I want to write down, what I do know. What I do know is I know the sine of a minus b. I'll write this over here, sine a, cosine b, let's see, minus sine b, cosine a. I do know that much. I know the sine of a minus b. I know the cosine of a minus b as well. What is going to be cosine a, cosine b, plus sine a, sine b. All right. Now, here's what they want me to verify. I'll point out to you, I know the tan of a minus b is sine over cosine of a minus b, a minus b. They want me to verify that this is true. I want to point out there's conventions over here, and the convention is we want this to be the number 1. So what I'm going to do is divide every term in the problem by cosine a, cosine b. All right, let's do that. And as I do that, I want to point out it's pretty easy to do. All right, not to memorize, but to do. So I want to point out I'm dividing every term by cosine a, cosine b. I would get 1. The second term on bottom would be sine a over cosine a would be tan a. And sine b over cosine b would be tan b. Now, if I divide the top, again, we're dividing the top by this here, every term. What would we get? We would get tan a. And let's see, well, cosines would cancel off. Cosine b over cosine b is 1. Minus sine b over cosine b is tan b. And what would you get over there? Cosine over cosine a, which is cancel off. All right, so we verified what we're supposed to, which is this thing over here. We've actually verified it. Let's do the second one. And it says, while you're at, why don't you do this one too? Let's write it down. We're doing the same exact story. You got sine a, cosine b, plus sine b, cosine a, cosine b, minus sine a, sine b. All right, what did I do over there? Let me point out to you. Tan of a plus b is sine of a plus b over cosine of a plus b. I just put the expansions down for those things over there. Then we want to see if we get this formula over here. Same story. We're going to divide top and bottom, every term, by cosine a, cosine b to make it a 1. All right, convention. All right, let's put that down. And let's show you we get it. We get 1 minus, well, let's see, sine a over cosine a is tan a. And sine b over cosine b is tan b. That was easy. Again, I want to remind you, we're dividing top and bottom by this guy here. What do you get? Sine a over cosine a, which is tan a. And cosine b over cosine b would be 1, plus, well, let's see, I would get sine b over cosine b, which would be tan b. And cosine a divided by cosine a is 1. So are we getting the formula they said? Of course we are. We're getting that formula. Now, what do they want me to do? They want me to use the formula on this one over here. Well, it should be fairly easy to do now. And the question is, it's the first formula. It's this one over here. It's a cosine of a difference. I'm looking at that. I see it. So what's it going to be? Well, looking at it, I'm sorry, I don't want to rewrite the problem. I'm going to erase that because I don't want to rewrite the whole problem again. Just waste time to rewrite things. All right. What's that going to be? It looks like the tan of a minus b. I'll write this over here. Tan of a minus b. 153 degrees minus 87 degrees. What's that going to give me? Tangent. Let's see, 13, 56, 66 degrees. Have we done what they've asked to do? Yes, we've written it as a tan of a single angle, which is right over here. All right, let me do number 4. All right, number 4, again, if I'm looking at it, I want to emphasize that they want me to do cosine of b minus a. This is number 4. Again, I need to know the formula. Some people say, oh, they're different letters or they're different orders. It's a formula. Cosine b, cosine a, plus sine b, sine a. Well, there's going to be 4 things to determine. All right. Now, I know the sine of a is 5/13. I know the cosine of b is minus 3/5. What I don't know is cosine of a, and I don't know the sine of b. So I need to figure that out. And I'll write this on the side for you. So if the sine of a is 5/13, the big question is, what's the cosine of a? Well, that depends on what quadrant it's in, and it's in the second quadrant. So if it's in the second quadrant, I know the radius is 13 just by looking at the sign. Radius of circles, radius 13. The ordinate would be 5. The abscissa has got to be negative. It's in the second quadrant. I just don't know what it is. So let's write this down. 5 squared, 25. I'm using the x squared plus y squared, by the way, plus x squared. That's the abscissa, equals 169, which is 13 squared. What does x squared equal? 144. I hope you realize that x could be plus or minus 12. But again, what am I doing? The abscissa, I'm in the second quadrant, has to be minus 12. So now I know the cosine of a, which is minus 12/13. All right, let's talk about I know the cosine of b now, right? And what's that going to be? Minus 3/5. I know b is also in the second quadrant, right? What I don't know is I don't know the sine of b. I do know the radius is 5, though. And that's the ordinate, and the ordinate in the second quadrant is a positive number. So I know whatever this is a positive number. All right, positive. Let's write this down. So minus 3 squared is 9, plus y squared, the ordinate, and the radius is going to be 5, which is 25. So y squared would equal 16. So y could equal plus or minus 4, but in this case here, it's in the second quadrant, the y value would be 4. So what do you get over there? 4/5 for b, for the cosine of b. Can I do the arithmetic on that? I think so. And I get 65. And what do you get there? You get 36. Minus 3 times minus 12 is 36. Plus 20, which is going to be 56 over 65. All right. Again, I want to point out to you, the answer is, 56 over 65. The answer is the next page, by the way. And I'm seeing it right over there. All right, let's go to number 5. And number 5 is very similar to what we just did. It's a summation of 2 angles, alpha and beta. It's going to be cosine alpha times cosine beta minus sine alpha sine beta. All right, there's 4 things to know. And I think they told me some of those things. For example, they told me the sine of alpha is 12/13. They told me the cosine of beta is 8/17. All right. Now, they also told me that alpha and beta are acute, which is good to know. If I know they're acute, I probably could figure out pretty quickly. All right, let me write this down for you. 12/13 cosine of alpha. Now, again, if alpha is an acute angle, it's got to be positive in the first quadrant. All right, radius is 13. And I think I'm getting better at this. So, I'm going to say, x squared plus y squared. Well, y is 12. That's 144 equals 13 squared, which is 169. So x squared would equal 25. So x would be plus or minus 5, but I'm in the first quadrant, so the x has to be positive. So what do I know now? I know the cosine of alpha is 5/13. All right, let's do another one. And I'm going to put down the cosine of beta now. And I know that to be 8/17. So what do I know? Beta is also acute. It's in the first quadrant. So the sine of beta has to be positive. Radius is 17. So what do I know? Let's write this down. I know x is 8. That's the abscissa, which is 64. Y squared equals 17 squared, which is 289. All right, let's keep going. Hoping these numbers work out nicely for you. So what would you get over there? If I did that, let's see, 64 from 289, 5, 2, 225. So y would be plus or minus 15. But again, we're in the first quadrant and the y is positive there. So I got this over here. So it's 15. All right. What does it mean? Sine of beta is 15/17. All right. Let me just make sure you can do the arithmetic now. And the bottom, it's 13 times 17, which is 221. Hoping it goes you fast with that. And what do you get there? 5 times 8 is 40. Minus 12 times 15. Well, that's not too bad. 150 and 30, 180, right? And 40 minus 180 is minus 140 over 221. Okay? Okay. Number 6, a little more complicated. Something to do with a formula that I would say that, some teachers say, oh, you have to memorize these things. I don't think you need to memorize much, except for the first formulas they're giving you, which is sine of a sum, sine of a difference, cosine of a sum, cosine of a difference. All right, let me write these down for you. It's important you know how to do this. You should definitely know this guy. You should definitely know this guy. You should know this guy. And you should know this guy over here. Now, some would say, if I know them, do I need to write them down? Not really, but I'm going to write them down anyway. Point out what I'm going to do. It's going to be sine of A cosine of B plus, I'll push this over a little bit. Sorry about that. Sine, I'm sorry. Yeah, so I do put an R. Sine B cosine A. Sorry about that. Sine A cosine B minus sine B cosine A. This one's going to be, let's say, cosine A cosine B minus sine A sine B. This one's going to be cosine A cosine B plus sine A sine B. Now, so why do you need to write those down? You don't. You don't need to write them down. What you need to understand is there's something to do with the problem. And I'm looking at this thing. I want to point out, I'm really looking at sine 3x times the sine of 5x. So my goal is they want to express this as a sum. So I need to find products. And I want to write it as a sum. I want to tell you I'm seeing products. And I want to tell you where I'm seeing those guys over here. I'm seeing it here. And I'm seeing it here. So I'm going to use these two here to write a formula down now. And I want to write the formula down for you. So what I'm going to do is I'm going to subtract them. I'll write this over here. Cosine A minus B minus cosine A plus B. You may wonder what I'm doing. I'm subtracting. So we did cosine A minus B minus cosine A plus B. And what would that give you? 2 sine A sine B. That may take you time to think through that, but you want to think through it. So let's write this over here. Cosine of A minus B minus cosine A plus B over 2 is the same thing as sine of A sine of B. Now, this is where a lot of teachers say, oh, you need to memorize that. I don't think you need to memorize. You need to understand that. All right. Now, the question is, what's A? Well, looking at this over here, the A would be 3x and the B would be 5x. Let's write this down. So it's going to be sine 3x times sine 5x. We're using this formula here. 2 cosine, what's a? I think it's looking at it. I'm going to say a is 5x. All right, so 5x minus 3x. I'll write that down for you. Plus, I'm sorry, not plus, minus cosine a plus b. 5x and 3x is 8x. I'll do that in a second, though. So what do you get over here? Cosine 2x minus cosine 8x over 2. Look at the key. And when you're seeing over there, you're seeing that answer. All right, let's go to number 7 now. And I'll pull this on the side a little bit. And maybe I should just pull this one away. Let me just push this on the side here. All right. So I'm getting more familiar with these problems over here. And I want to point out what I mean by that. I know I need the sines and cosines of these numbers to do the problem. So that's something to do with that. So I'm going to write down sine of A is 1/3. And I'd like to know what the cosine of A is. We'll get that later. They also know the cosine of B is 2/3. And I'd like to know what the sine of B is. Now here's a problem over here. I need to know where A and B are. So let's talk about it. It goes on to say that they both, both the angles are in the fourth quadrant. So what do I know about that? The cosine would be, let's see. I'm sorry. A terminates in the first quadrant. I'm sorry. I misspoke over there. A is in the first quadrant. Well, that's pretty easy. So what do you get? I'm getting a little better at this. I'm going to say I know the radius is 3. I know the y is 1. I don't know the x yet, right? So x squared plus y squared is 1. And the r squared is going to be 9. So x squared would equal 8. X would equal plus or minus 2 root 2's. All right? But remember, A is in the first quadrant, so the x has to be 2 root 2. All right, let's go to the next one. And the next one, I'm going to look at it. And I'm looking at, again, I'm looking at this as sort of like saying, x squared, y squared, r squared. Well, I know the r is 3. I don't know the y yet. So I'll write this one over here. X squared is going to be 4. That's 2 squared. Plus y squared is equal to 9. So y squared would equal 5, or y would equal plus or minus the square root of 5. Here's the deal, though. Where's b? B's in the fourth quadrant. So what's y in the fourth quadrant? Definitely negative. Let's write down what they want to know. They want to know the cosine of a minus b. What does this give you? Cosine a, cosine b, plus sine a, sine b. Let's write it down. Cosine of a, 2 root 2 over 3. Cosine of b is 2 over 3. The sine of a is 1/3. And the sine of b is minus 5. Minus root 5 over 3. Yes, you're expected to do arithmetic. Common denominator is 9. You would get 4 root 2 minus root 5. Do mistakes happen? Of course they do. So this, again, I keep repeating over and over again, this is why you want to make some attempt to look at the answers and verify that what we're saying is in fact true. All right. So we just did number 7. The answer's on the following page. Look at it. Make sure you get the same answer, which is 4 root 2 minus 5 over 9. Like we said, 4 root 2 minus 5 over 9. All right. So number 8, I got to be honest with you. A lot of people look at these problems and say, I don't even know where to start with these problems. And that does happen. All right. So I'm going to pull this one aside. And you want to identify this identity. By the way, the footnote says you probably should look back in your notes. And what does that mean? You really probably should be studying at this point. And what I want to do is I want to see if I come up with this and see if I can figure it out. Well, how do I do it? I got to pick one of the sides and rewrite it so it looks like the other side. And I'm going to pick the left side. So if I were like on an exam, I would definitely circle the left side. Now, here's my problem. I got to get a formula for that, and I can't remember those formulas. And I would be looking back in the notes in the exam. I can't do that. So I'm going to write down what I need to know. And let me write this down for you. You need to know the sine of a plus b. I need to know the sine of a minus b. I need to know the cosine of a plus b. And I need to know the cosine of a minus b. There's 4 things to know in this section. So it's going to be sine a cosine b, and plus on the side. Okay? And then it's going to be plus sine b cosine a, sine a, cosine b, minus, sine b, cosine a, that's not so bad, cosine a, cosine b, minus sine a, sine b, cosine a, cosine b, plus sine a, sine b. And I got that you should know those. Here's the deal, though. I'm looking at the top, and it's a difference in the sine values. All right. So what I'm going to do is I'm going to take this, and I want to write down their difference now. So I'm going to write down sine a plus b minus sine a minus b. And what's that going to give me? That's going to give me 2 sine b cosine a. I'm going to look at the bottom, and it's a sum. I'm going to add these 2 together now. What do you get? Cosine a plus b plus cosine a minus b equals, let's see if I did that. What would I get? If I had those 2 together, I would get 2 cosine a cosine b. So I think I'm getting close. I want to point out what do I mean by getting close. I'm looking at this thing, and I'm going to say that it looks sort of like, I'm going to just put a fraction bar here, right? So I'm going to get my little eraser out. I did my formulas. Let me get my little eraser out and erase this, and divide these 2. And I'm going to simplify it. What would that give you? Well, the cosines definitely disappear, and the 2 disappears. And what are you left off with? Well, I guess you just left off with the sine over the cosine, which is the tangent, right, of b. I have this little formula there, don't I? It's not the same problem, though. I'll tell you why it's not the same problem. I don't have a and b in it. I want to claim to you what I do have, though. I want to tell you what I have a plus b here. And what's a plus b is 3x. And a minus b is just x. And a plus b is 3x. And a minus b is x. All right? But I still don't know what b is. So I got to figure that out. All right, let me write this down for you. 3x equals a plus b, and a minus b is just simply x. This is 3x. I'm going to add these together. 4x equals 2a, which means a is equal to 2x, and b would just equal to x. So I think I'm okay here. I'll tell you why. I think I'm ready to go. And what is it? I'm looking at this thing, and I pretty much just verified with all that work over there that I know what this thing is over here. And what is it? It's just simply going to be the tangent of x, which has got the b over there. We just verified this. All right, let's go to number 9. And number 9 says evaluate the sine of 15 degrees. And I got to go back to get 9 for you. Give me a second. Number 9 is evaluate sine of 15. There's many ways to do it. Don't think there's only one way to do that. And I'm looking at it, and first, the way I would do that is say, do I know it's related to some formulas? I'm pretty sure it is. So I'm going to say the sine of 15. Well, I'm going to say it looks like a difference to me. So I'm going to put down the sine of 60 degrees minus 45 degrees. I hope you can agree that's at least 15 degrees there. Let's keep going. It's a formula. It's a difference. Sine 60, we'll do that later, times a cosine of 45 degrees minus sine of 45 degrees times the cosine of 60 degrees. And you show to figure this thing out. Sine of 60 degrees is root 3 over 2. The cosine of 45 degrees is 1 over root 2. Minus the sine of 45 degrees is 1 over root 2. And the cosine of 60 is going to be 1/2. Common denominator is 2 root 2. Numerator is root 3 minus 1. Look at the answer. And what do you see? Oh, I got a different answer. Let's take a look at it. By the way, I'm not saying it's the wrong answer. I said their answer looks different. What they look like they did was multiply top and bottom by root 2, right? So a rationalizing factor. Let's go through that. Where's this over here? Put a rationalizing factor in. I want the top and bottom by root 2. What do you have over there? On bottom, you get 4. On top, you get root 6 minus root 2. Is that the answer they have? No, it's still not the answer. What do? They factored out root 2. What did they get? Root 3 minus 1 over 4. That's the answer they got. Someone says, what answer is a good answer? A correct answer is a good answer. There's various forms of it, but the bottom line is be aware of that. All right, so let's take a look. And I'm looking at number 10 now. And number 10 looks like a tough one, doesn't it? And it says, rewrite the expression in terms of first powers of the sine. First powers of the cosine. And oh boy, this looks like it might be really tough. All right, so let's take a look. And I know it looks kind of complicated, but I know it has something to do with those 4 formulas I talked about, right? So I'm going to maybe write that down for you. So sine. I realize all this is it takes too much time for me to do this. And we're going to say that in education does take a lot of time. Let's see, sine of A, cosine of B, sine of A, cosine of B. Oh, let's see, cosine A, cosine B. I'm not done yet, right? Cosine A, cosine B, plus sine B, cosine A minus sine B, and going to be cosine A minus sine A, sine B, minus, let's take a look at this thing over here. I'm sorry, not minus, plus sine A, sine B. Again, it has something to do with those 4. Something to do with it. All right. So let's take a look. And I'm noticing they both have the same argument, right? X over 2, X over 2. That looks pretty simple. So I'm going to say maybe if I made them the same argument, let me write this down. So I'm going to simply say sine. And I'll write this down for you. X over 2 plus X over 2. What would that give you? Well, that doesn't look too bad, does it? You get sine X over 2 cosine X over 2 plus sine X over 2 cosine X over 2. All right, you get the idea, right? I keep doing this, but I'm going to say, let me just erase that. And, maybe that's some double angle formulas over here that we could do, because it looks like we just did this before, right, with double angle formulas. Let me write them down for you. I'm going to get my eraser out. And I'm still looking at those four formulas, but I got the same argument. Put this down for you. So cosine, I'm sorry, I shouldn't say cosine. It'd be more consistent, right? I'll give it sine of the double angle, 2x. What does that equal? Well, kind of looking at it would be 2 sine x. Again, I'm just using the formulas that we have above, cosine x. Which formula did I use? This one over here. All right, let me put down the cosine of 2x. All right, it's getting kind of warm here, isn't it? So I'll take a look. It's over here and put this one over here. What would that give me? Cosine squared x minus sine squared x. All right. Double angle form. So let's take a look at this now. I'm going to write this down for you. So I'm kind of looking at this, and I'm just going to put a double line over here. And I'm wondering how this is related to that. And let's write that down for you. So it's going to be 3 times sine x over 2 times cosine x over 2 squared. All right, now do I see that up there? Well, sort of. All right. What I mean by sort of, I'm seeing sort of, and I want to point out what I'm seeing. I'm seeing this. All right, but not totally. And I'll tell you why I'm not seeing it totally. I'd have to divide both sides by 2. But what would I get over here? Let me write that down for you. 3. I'm seeing this part of it. And what I see, the sine, right? Twice the argument, which would be x. All right, twice the argument, right? It's x over 2, over 2. All right, let's keep going and see if I can figure that out now. So what do you get there? You would get 3. Let me just put this down for you. Quarters. And you would get sine squared, right? All right, I got troubles. I want to tell you why I have troubles. I'm reading it says rewrite the expression in terms of first powers. I still got a square. So I want to keep going. And I'm going to be using this guy now. I got to get sine x. No, sine squared. So I'm going to write this down for you. And again, this is all coming from, basic identities. The cosine of 2x is equal, what's cosine squared? It's 1 minus sine squared. So 1 minus sine squared minus 2 sine squared would be 1 minus, whoops, sorry about that. It would be 1, I lost track what I was saying over there. Oh, sine squared. So it's going to be 1 minus sine squared, so 1 minus 2 sine squared. Let's keep rewriting it. I would get 2 sine squared equals 1 minus cosine 2x. I'm getting really close now, aren't I? Let's write this down. 3/4. And what's sine squared equal to? 1 minus cosine 2x over 2. And I think I'm done. Bottom is 8. Top is 3 times 1 minus cosine 2x. Okay, look at it. We got it right over here. Again, they multiplied through by 3, but it hasn't changed it much. All right, let's take a look at number 11. And let's see if we can do it. And I'm going to look at it. And this is number 11 now. And what do you see? They want to evaluate the tangent of beta plus pi over 6. All right. Now, some of I can't remember, but I think I've done something like this in a prior example. And you have. It's a tangent of a sum. So I'm going to write down what it's going to equal, and then we'll evaluate it, talk about it. So it's going to be tan, and we derived the formula before, of beta plus the tan of pi over 6. We'll do that later. On bottom, it's going to be 1 minus the tan of beta times the tan of pi over 6. All right. Now I got to do it. And that can be very difficult to know where it's going to go. This is why we give you answer K. And let's see if I can do that. And what's the tan of pi over 6? Well, let me remind you. Pi over 6 times 180 degrees over pi. That would be 30 degrees, right? So I'm pretty clear about that. They can do that. Tan of beta plus the tan of pi over 6, 30 degrees. That would be 1 over root 3. 1 minus tan of beta times 1 over root 3. I would multiply top and bottom by root 3, and you would get root 3 times the tangent of beta plus 1. And on bottom, you would get root 3 minus the tan of beta. I can't say this enough times. I want to encourage you to look at the answer key, and you should be staring at that answer, which is in the following page. So in the following page, look at it, make sure you can agree with that. All right? If you can't agree with that, something's wrong with it. The next page. And I'm seeing it right there. All right, let's go to the next one. And it's number 12. Number 12 says, suppose that A is in degrees, measure for an angle. Yeah, simplify. Well, let's write this down. Now, again, someone says, I got a fast way of doing this. We're not saying you can't do it quickly, but I'm going to write this down for you. So sine of 720 degrees, whoops, plus A. Now, what do I mean by a fast way of doing this? What I've noticed is that 720 degrees is just simply twice around. So this should be the same thing as the sine of A. Let's go through it though. Sine 720 degrees cosine A plus sine of A cosine 720 degrees. Well, the sine of 720 degrees is 0 times cosine A, sine A, and the cosine of 720 degrees is 1. So we get sine A, as we expected. All right, half angle formulas. I know it's tough. I just want to go through it real quick with you. All right, there's other ways of doing this thing, but they say use the half angle formulas. People are often confused by this. This is why I put a lot of work down for this one over here. But what I want to do is I want to go through the half angle formulas for you. All right. So one thing you need to know is, and hopefully you're getting a little better at this, you would need to know the sign of a double angle formula. So I'll put down 2x. And what's it going to be? 2 sine theta, I'm sorry, sine x, cosine x. You would need to know that. The other ones you need to know is the cosine of 2x. What's that going to be? Cosine squared x minus sine squared x. These are the double angle formulas. This is also going to be 2 cosine squared x minus 1, or 1 minus 2. Oops, I need to do that. 2 sine squared x. Well, let's talk about half angles, all right? So what I'm going to do is look at this formula over here and see if I can figure it out, all right? So I want to memorize them. We're not going to stop you. Well, I'm going to write this a little differently. I'm going to divide through by 2. Well, I think I have it. So I'm going to say the sine squared theta over 2 is going to be equal to 1 minus cosine theta over 2. All right. So I just said x was theta over 2, and 2 times theta over 2 is just theta. All right. So I'm going to say you could probably do the other one. I'll write that down for you. And again, we're just deriving things. Hopefully by practice you get better at it. I'm going to say, let's see, cosine 2x plus 1 is 2 cosine squared x. I'm using this over here. And let's see what you got over there. I would say cosine 2x plus 1 over 2 is cosine squared x. I think I have another formula to write down for you. I'll put that over here. So I'm going to put down cosine squared theta over 2 is the same thing as 1 plus cosine theta over 2. So that's two pretty important formulas. And I'm going to say I need to know those. All right. So what do they want to do? They want to do sine of 165. I'll put this over here. The sine of 165 degrees. All right. Now I'm going to write this down instead. I'm going to write down the sine squared. What would the theta be for it to be if I divide 2 to get 165? That would be, let's see, 160 and 160, 330, right? That's 165. And what would that equal? 1 minus cosine, right, of 330 degrees now over 2. All right, let me write this down. Sine squared 165 degrees is 1 minus, well, 330. The reference would be 30. So that's going to be what? I'm in the fourth quadrant. So that's going to be minus root 3 over 2. I'm going to multiply top and bottom by 2. You would get 2 plus root 3 over 4. And that's sine squared, 165. Here comes my problem. I didn't want the sine squared of 165 degrees. I wanted the sine of 165 degrees. Now here's the problem. It could be plus or minus that. But I hope you realize that the sine of 165 is in the second quadrant, and it's got to be a positive number. So it's going to be the square root of that number. So it's going to be the square root 2 plus root 3 over 2. All right, I'm going to go back up here, and I want to point out the answer we're looking to get from you. And I think I made a mistake somewhere. And let me see where I made a mistake. Oh, I see I made a mistake, a copy error. I'm going to go back over it and correct it. All right, sorry about that. I'm going to get my eraser out. I got this over here. I think I made a mistake. I got to figure out where the mistake came from, don't I? I don't think I made a mistake somewhere. Sorry about my machine seems to be, gonna make a look at this 165. Did I make a mistake somewhere? 13. Let's take a look. And this is a problem. You have to look at something, find my error. 165. Oh, let's see what I got here. Sine theta over 2, 1 minus cosine. Oh, now I know what I did. I see it. That's important. Let me get back my pen over here. This is actually this. This is actually this. Let me get my eraser out. I'll erase this business over here and write it down again for you. Sine, that's going to be the square root of that, which is going to be 165 degrees. It's going to be the square root 2 minus root 3 over 2. And that's the answer they're providing it over here. Let me point that out to you. That answer is right here. I do want to point out I do a lot of work on that one over there. You're not expected to do all the work on it. All right, so I got that covered. And what I want to do is I want to go to the next one, which I believe is a cosine of 165. I'm sorry, the sine of 165, cosine of 165. Put this over here. All right, I'm going to pull this over here and point out the one I'm going to be using now is I'm going to be using this one over here. What's that going to be? Cosine squared, 330 degrees over 2. All right, let's keep going. Oops, sorry about that. Which is going to be equal to 1 plus the cosine of 330 degrees over 2. This is the cosine squared of 165 degrees, by the way, would equal 1, and the cosine of 330 degrees is root 3 over 2. Over 2. Cosine squared, 165 degrees. I can multiply top and bottom by 2. This would be 2 plus root 3 over 4. And now what I got to do is figure out what the cosine of 165 degrees is. And it does require some thinking. And what I mean by that, it could be plus or minus. I hope you realize we're in the second quadrant. It's got to be negative. So it's minus the square root 2 plus root 3 over 2. All right. And then the last question, I believe, is the tangent of 165. Let me make sure what I mean by that. The tangent of 165 degrees. And that's going to be the sine of 165 degrees. I don't need a formula for that, by the way, over the cosine of 165 degrees. Just simply take the ratio of those two, and I'll put that down for you. Fairly simple to do. You would get this over here. I know it's over 2, by the way. And the bottom one's going to be minus this over here. I'm going to simplify that by multiplying top and bottom by actually minus 2. And you would get this over here. All right, looks pretty complicated. And I'm going to say, you put it down as an answer if you want, but I'm going to simplify that. We'll look at the key later. And I'm going to multiply top and bottom by the conjugate. I'm going to erase around. We'll look at the key later, by the way. When you get here, well, 2 minus root 3 times 2 minus root is 2 minus root 3 squared. So the top would be 2 minus root 3. There's still a minus sign on the outside, by the way. And the bottom, what do you get in the bottom? That would be 4 minus 3, which is 1. Wow, that turned out to be pretty nice. And what do you get? You're going to get root 3 minus 2. Put a circle around that. Okay. What I'm going to emphasize here is that you definitely look at the key. We've already verified the sine of 165. Next question is cosine of 165. I wrote the answer down, which was, minus. And I'm agreeing with my answer key. This is good. And I'm agreeing with my answer key. This is good as well. All right. I think that brings us to a point in the notes. I want to point out where we are about something that's optional. And what do you mean by optional? A lot of students look at this stuff and they have a tough time wading through it, but it's something about denesting roots. You don't have to do it, but if you notice some of my answers, I actually denest the roots. All right, let's go to number 14. And number 14, I'm not going to do the optional thing, by the way, but you can read through that. And again, your education depends on your reading. You want to read that, that's fine. So I'm going to do number 14. And it says, given the tangent theta is minus 3/4, I'll write that down for you. This is 14. It says the tangent of theta is minus 3/4. And it goes on to say it's in the second quadrant. All right. And it says, find each of the following. And I'll write them down. The first thing in A, it says, find the sine of 2 theta. Well, you would need to know the formula. And again, it comes from those 4 formulas we addressed many times before. 2 sine theta, cosine theta. All right. I got a problem right now. I know the tangent of theta, but I don't know the sine or the cosine. What I do know, I know it's in the second quadrant. So I could probably put down something over here. I want to put that one I could put down. I could probably put down the sine of theta and the cosine of theta. I could probably put their sine down now. And what's the sine going to be? Well, the sine in the second quadrant for the sine is going to be positive, and the cosine is going to be negative. All right, so let's see if you can figure it out. And someone says, what do those letters mean? And hopefully you realize it's something to do, the tangent, something to do with the x and the y. And the x would be minus 3. And the x is minus 3, so this is going to be 9. And the y is 4, so it's going to be 16, which means my r squared is 25. So r is the r is 5. Positive number. What I say the x is? Minus 3. And the y was going to be 4. Let's write this down. 2. What's sine theta? 4/5. What's cosine theta? Minus 3/5. All right, 25 in the bottom. On top, you can get minus 24. That's done. Okay, again, the claim is we give you answers for a reason. We want you to look at those answers, and it says minus 24/25. Let's go to B. All right, and B is the cosine of 2 theta. What's that going to equal to? Cosine squared theta minus sine squared theta. By the way, there's 2 other identities that you need to know, but right now we'll just use that. I already did the cosine of theta. That's minus 3/5. When you square that, you get 9/25. Minus, when you square the sine, you're going to get 16/25. What is that going to give you? Minus 7/25. Put a circle on that. The last one they ask you for, I think I made a mistake somewhere. Cosine 2 theta is 7/25. Cosine 2 theta. Cosine squared. Second quadrant. Boy, I'm making some mistakes, aren't I? Let's take a look at it. And 10 minus 3/4 second quadrant. Sine of 2 theta I got right. And the cosine of 2 theta. Yeah, I wrote a bad formula down. Let me erase it. That happens when I'm not thinking. I got to erase things over here. All right. So cosine 2 theta. Cosine squared theta. Minus sine squared theta. I got to really think about this now because I made a mistake somewhere. Tan theta. I get things backwards or something? It's possible. Second quadrant. Sine is 4/5. Oh, now I'm seeing it. I'll tell you why I made a mistake. And I want to draw a picture of it. All right. And just not thinking. That's a problem. And you really want to, if you look at something that's not right, you want to make it right. So I'm going to start to, I got my formulas good. Get my eraser out. And I want to draw a picture of this. And I said something, right? And what I say that, looking at the tangent is minus 3/4. And I said something that's incorrect. All right. So what am I saying over there is if I drew a picture of it, and I'm going to say it's over here somewhere on the second quadrant. What do I know? Again, I'm not saying it's an accurate picture, but I know something. I know the x coordinate is going to be negative. I know this is negative. I know this is positive over here. And that's where I made my mistake. And it's going to be, this is going to be 3 over here, and this will be 4 over there. All right. And this is where I made my mistake. And I got to correct it. And someone says, why do you need to correct it? Hey, putting the wrong things is not right. All right. I'm going to erase this business over here. 1 second. Don't be discouraged by making mistakes. All right, let's write these correct answers down now. And the sine of is going to be 3/5. And the cosine is going to be minus 4/5. All right, we got that over there, by the way. So let's write this one down. 2 times 3/5 times minus 4/5. That's going to be minus 24/25. 25ths. I got that one covered. Let's do this one over here. Cosine squared. I'm looking at 16 25ths, and sine squared is going to be 9 25ths, which is 7 25ths. So I'm feeling more comfortable in getting the right answers. And now I'm going to put the tangent of 2 theta down. That's going to be C. The tangent of 2 theta is quite easy to put down. It's really the sine of 2 theta over the cosine of 2 theta. What's sine of 2 theta? Minus 24 25ths. What's cosine of 2 theta? 7 25ths. What does that give you? Minus 24 sevenths. Again, look at the answer key. Make sure you can agree with that. All right, let's go to the next page. And we're going to do problem number 15 now. All right, I'm going to look at it, see if I can do it. And they tell me that they want me to simplify it. And to simplify that, I'm going to kind of, maybe I'll pull this one to the side a little bit. I'll push this over here. Let's just write this down. So what do you get over here? This would be the sine of V times the cosine of X plus the sine of X times the cosine of V minus, well, let's take a look at this, sine of V cosine of X minus sine of X cosine of V. And subtract those guys. What's nice, something disappears, and we left off with 2 sine X cosine V. All right, let's go back over here. And I want to point out that's what you're staring at over here. All right, let's do number 16. I'm going to pull on the side. And I'll see if I can do it. All right. And then we're going to simplify this one as well. I don't think that looks too bad. All right, we'll look at the key later. 2 sine X cosine X over 2 cosine squared X. Well, there's some cancellation, certainly. The 2's cancel, and one of the factors of the cosine cancels. So we left off with sine X over cosine X, which is quite simply tangent of X. Again, look back at the key, and you're seeing that over there. All right. Oh, boy. One of these product things again. They want me to simplify it. Let's write this down. 17. And I want to simplify sine of 5x times the cosine of 2x. Again, I realize for a lot of students are looking at saying, these things, you keep writing these things down. Could you memorize these guys? You could. But I'd be honest with you. Some people may disagree about how simplification is here. But I got to be honest with you that this is a product, and my claim over here, sums are a lot easier than products. That's my claim, all right? So what I'm going to write down is, I'm going to write down 2 formulas, all right? I'm going to write down the sine of A plus B, and I'm going to write down the sine of A minus B. And these should be sort of like burned in your memory at this point. And what's going to be sine A cosine B, right? We've done this before, right? Plus sine B cosine A. And this is going to be what? Sine A cosine B minus sine B cosine A. All right, I got those two. I sort of remember those two. Cosine A plus B, I'm sorry. And cosine A minus B. All right. If you write those down, what you get? You'd get, let's see, cosine A, cosine B, cosine A, cosine B, minus sine A, sine B, plus sine A, sine B. All right, so let's look at them. Someone said, why are you looking at them? I'm looking at this over here, and I want sine cosine. Right, so sine cosine. I want sine times cosine. So I'm good looking at that sine times cosine, right? Sine times cosine. I'm seeing it. I'm seeing the sine times the cosine. I'm seeing them all over the place. All right, and which one are you going to do? I guess I'd pick these two over here because I'm seeing sine and cosine as a product. And how am I going to do that? I'll write this down for you. So I'm just going to add them together. What would you get? Sine A plus B plus sine A minus B, I'm adding them together, is going to be 2 sine A cosine B. All right, let's write this over here. And before I do that, though, I'm going to divide both sides by 2. Just give me a second. Erase this here. Okay, let's write down what we have. And again, I want to point out that some people say, I don't think this is a simplification at all. You're making it more complicated. We'll talk about why it's a simplification. All right, let's write it down. 2 sine, well, I'm looking at it. A is 5x, B is 2x, 7x. And sine, what's A minus B? 5x minus 2x is 3x. All right, let's talk why it's simplification. Sums are considered easier than products. And we have a sum. Well, we definitely have a sum down. All right, I'm going to say it's a simplification of the problem. All right. Now, granted, at this level of the game, we probably would say rewrite the product as a sum, and we're using those formulas over there. All right, let's go to the next page, and which is number 18. By the way, the answer is written over there for you. So let's put down this. I'll pull it to the side. Don't be discouraged if you find this difficult. Let me just undo that and do a very good job there. You know what? I'll just blow it up, and we'll take a look at it. So they say simplify, sine 2 theta over 1 plus cosine 2 theta and use it to derive the formula. And you might look at this and say, oh, the work is already down there for me. Let's take a look at the work. We'll put this down. All right. So I'm seeing sine 2 theta. They say simplify this guy over here. So I'm going to put on, I wrote that down for you. Sine 2 theta, 1 plus cosine 2 theta. You should know the cosine of 2 theta is 2 sine theta cosine theta. You should also know that the cosine of 2 theta is 2 cosine squared theta minus 1. And if you simplify that, you would get, well, let's write that down for you. Certainly, so I'll write this over here. This would be 2 sine theta cosine theta. And on the bottom, what do you get? You get 2 cosine squared theta. Now, granted, I'm seeing that here, but what they did was they wrote it down twice. All right, you get the idea? I wrote it down twice. What happens? 2's would cancel. Hope you realize that. One of the factors of sine would cancel. And what do you get? Sine over cosine, which is tangent. Whoops, sorry about that. All right, you get that. All right. You know what? I'm going to erase it because it's in red ink. It doesn't look right. It just simplifies the tangent. I did it again. All right, write that down for you. So the sine of 2 theta over 1 plus cosine of 2 theta is same thing as tangent of theta. They said this to derive a formula for this one over here. So really what I'm doing, I'm taking theta and I'm making it x over 2. And what do you get over there? Sine, well, if theta is x over 2, what's 2 times x over 2? X. 1 plus cosine. Again, if theta is x over 2, what's 2 times that? Would just be x, which you asked me to derive that. That's a nice formula. Again, I'm not going to say you need to memorize that, but it's a nice formula. All right, thank you.